Okay, so we're now on to looking at some past paper questions in the Nat 5 trig equations topic. So we've got two to show you in this video. One of them related directly to a trig graph, and the second is related in a kind of real life context, which they often like to do in an exam. So the first one, we've got part of the graph of y equals a cosine x plus b is shown below. Explain how you know that a is equal to 3 and b is equal to -1. So this is actually relating back to our knowledge on trig graphs, knowing that a is to do with the amplitude, the maximum and minimum values, and plus b tells us that it's been moved up or down. So how do we know that a is 3 and b equals -1? This is just testing our understanding of the principles of amplitude and vertical shift. So remember, the amplitude, the definition we used before was that it is half of the distance between the maximum and the minimum. So the distance between 2 and -4 is 6. So half of 6 is 3, and that is what a is. A equals 3. So a, you can say a little statement like a equals half of distance between max and min i.e. half of 6, which equals 3. That's kind of an acceptable statement there. How do we know that b equals -1? Well, if we had 3 cosine of x, it would usually start up at 3, have a maximum at 3, it would usually have its minimum at -3, but we can see that both of those values are 1 below what they should be in inverted commas for 3 cosine x, so therefore the whole graph must have been shifted down one place, which means that value of b must be a -1. So 3 cosine of x has been shifted down by one place. Max has gone from 3 to 2, so therefore b equals -1. Okay, so just a wee bit of kind of revision, I guess, understanding of trig graphs. Now we're on to a trig equations, solving a trig equation, part B, 4 marks, which is calculate the x coordinates of the points where the graph cuts the x axis. Right, now the majority of Nat 5 pupils that struggle with this question is because they don't actually understand what the question's asking. Right, calculate the x coordinates, so that means where the positions on the x-axis, that's the horizontal one, where the graph cuts the x-axis. So look at where the graph cuts the x-axis. It's cutting the x-axis at this point here, just before 90, and this point here, just after 270. So how do we do that? Well, we solve the trig equation, right? We have the graph of y equals, we now know it's y equals 3 cosine of x -1, and we're trying to see where does that meet the x-axis. Now, x-axis would have a value of y equals 0. That's the whole point of this. Y isn't positive, y isn't negative, y is 0 along that line. So the actual equation we need to set up is that 3 cosine of x -1 is equal to 0. So if you can get to this stage, now it's just solving an equation, a trig equation, the same way we've been doing over the last few lessons, and you should be okay from here. So right, so rearrange to get just cosine of x, then we'll do our cast diagram and we'll do the whole thing. So +1 first, we'll get 3 cosine of x equals +1, divide by 3, we'll get cosine of x equals 1 divided by 3. So cosine of x is equal to a third, okay? Okay, so we can now get our acute angle by doing the inverse cosine of a third. And again, I would just put 1 divided by 3 into my calculator rather than trying to actually write a fraction. I'm getting 70.5 degrees. Now we need to do a cast diagram to determine what the other quadrant is for our second solution. So CAST, remember we take our lead from when we have our cosine fully rearranged, just the line before we do the inverse. So we've got x, 180 minus x, 180 plus x, and 360 minus x. What are the two quadrants where cosine is a positive value? Well, it's going to be A and it's going to be C. So A and C. So one of our solutions is just that acute angle x. So x equals 70.5 degrees. And our second solution is 360 minus 70.5. So 70.5 degrees and 289.5 degrees. And if you look back at our diagram, we can that kind of matches what we expected. We expected our answer to be just a bit less than 90 and a bit more than 270, and those two numbers do satisfy that. So we know we've done it right. Now, this example is in a real life context, which scares people, but we'll just go through it step by step. It's actually really straightforward. It's just solving a trig equation and doing a couple of other simple examples, simple calculations as well. So we've got a wind turbine that has 3 blades as shown. We've all seen them. It's up on top of the hills. The height h in meters of the tip of blade A, so I'm just going to highlight that, that's this bit here. The height of that in each rotation is given by this formula. So it's 40 plus 23 cosine of x, where x is a value between 0 and 360 because, this is a circular motion, so the angles are going to be between 0 and 360, then it'll start again because it'll be back to where it started. So it kind of ties in. This is any real life context question with trig equations is usually involves a kind of circular motion because that's where the trig graph angle whole fundamental theory comes from, is through a circle. So x is the angle that the blade has turned from its vertical position. So if it's vertically pointing towards the sky right now, x is the angle that it turns in a clockwise direction. Okay, so the first two questions are actually just straightforward, putting them into your calculator. So we've got calculate the height of the tip of blade A after it's turned through an angle of 60 degrees. So what we're asked for here is find the height when we know that x is 60. So there's actually nothing difficult about this. All we're going to do is we're going to write the equation, and instead of x, we're going to put a 60 in. And we don't actually have to do any rearranging, any inverse, any cast diagram here. That's literally just putting that line into your calculator. So pick up your calculators and do 40 plus 23 times the cosine of 60. Making sure that your calculator is, of course, in degrees. And the height, when it's turned 60 degrees, is 51.5 meters. Straightforward enough. Okay, the second, and you take your kind of lead from the marks of the question. If you can see both the marks here are 1 mark, it means we shouldn't be doing a lot of working to get this 1 mark, so it isn't that big long process. Okay, find the minimum height of the tip of the blade above the ground. Right, the minimum height. Now let's think about this logically. If we go back to the diagram, if we imagine this blade turning in a clockwise direction, the minimum height is when this blade is going to turn a full half turn, isn't it? It'll be when it's kind of down like this, right? And then it'll start going back up again. So the minimum height of the blade is going to be after it's turned 180 degrees. So that's actually all we're going to put in for x this time. It's knowing that it's a half turn, 180 degrees. That's what we're putting in for x. And we're just repeating the calculation, but with 180 in there. So 40 plus 23 times the cosine of 180. And if you put it carefully into your calculator, you should get an answer that logically should be less than part A because it's its minimum height. So 43 plus 23 times the cosine of 180 you're not doing an inverse again, it's just cos 180, and we get an answer of 17 meters. Okay, so hopefully straightforward enough so far. You just need to read the question very carefully to know what to do. Part C, calculate the values. Right, big clue here that straight away I know that I'm actually going to be doing my solving process because it says values, plural, for which the tip of the blade is 61 meters above the ground. Okay, so this time I know what the height is. I'm given the height of 61. What I'm not given is the angle. So I'm not given x. So difference this time is I'm putting 61 in for h, and I'm starting with the original equation. X has to stay there because I don't know what it is. This is the one where I'm now rearranging and solving for cosine x and doing my cast diagram and all the rest of it. Okay? So what I'm going to do here is we're used to kind of having the cosine on the left hand side, so we're just going to rewrite that. I think it's easiest. So 40 plus 23 cosine of x equals 61. We're going to take away 40 here, and then we're going to divide by 23. That's our kind of two opposite operation steps here. So take away 40, we're going to have 23 cosine of x equals 21, and divide by 23 to get our cosine of x on its own, 21 over 23. And let me make something clear, there's no need to figure out what the answer to 21 out of 23 is, like as a decimal, so don't bother doing that. You can just put it in as a fraction. There's no need to do that, because you'll then have to round it, and you won't be as accurate as if you just leave it as a fraction. Okay, so now we can get our acute angle by doing the inverse cosine of that fraction. So let's do that first. Okay, and you should get 24.1 degrees. Now we highlight or circle our equation when it's fully rearranged, and that's going to help us for our cast diagram. So CAST x 180 minus x 180 plus x and 360 minus x. So which two quadrants am I in? I'm in the two quadrants where cosine is equal to a positive thing, so that is the first one and that is the fourth one. So my two solutions, the first solution is actually going to just be the acute angle, so x is going to equal x is going to equal 24.1 degrees, and it's going to be 360 minus 24.1. So what are the angles that it turns that has a height of 61? Well, those angles are after 24.1 degrees of a turn, and then after 335.9 degrees of a turn.